Hi there, I'm John from CNCKing.com, and today we're going to manufacture this towel holder. This is actually not the towel they'll be using for this. The customer will actually be using paper towels, the white ones. So this is what I fabricated using welding. And it's just 3/8 plate, as you can see here, with holes of course, so they could put it against the wall. And 3/8 plate here. And here you have a tube, which I capped the top of it. Now the reason why the customer wanted me to make this for them instead of buying one is because they bought one at a store, they paid too much for it and it broke right away. They had a bunch of kids, so basically the kids would grab a towel and sometimes grab on this too, and basically what happened, it just broke apart. This thing here will outlast their great-grandchildren. It's already about, I would say about 3 pounds, and once they put it against the wall, they're not ripping this thing off, ever. If they try to pull it off, the drywall is coming off along with it. It's very, very strong. I can't even rip it apart myself. And yeah, so let's take a look at me welding this together. Like welding, when it comes to metal fabrication, there's a lot of different ways of doing the same thing. The first part of any sort of process is actually cleaning up the material. The reason why I clean the material is a couple fold. In this case here, I want to have everything relatively clean before I paint it so you get better paint adhesion. It also helps with the welding itself because when you have a clean surface, you have a lot less impurities, especially the mill scale and other things that are on the actual metal. And cleaning up means that more of the heat is put into the metal rather than on the surface of the metal. And all those impurities can also affect the quality of the weld, which is another reason to get rid of them. The other thing I'm doing as well with the angle grinder is actually getting rid of all the sharp corners because this is going in a residential house. And the last thing you want to do is for them to cut their hand every time they grab a towel. You know, it's a good way to get a lot of customers for towels, but it's not a good way to get repeat business. So after angle grinding all the edges, everything, cleaning everything up, the next step is actually cutting everything to size. And the reason why, again, I do all of this stuff before I do the welding, because once you have the whole welded assembly together, the problem is now you have some problems, you know, getting to certain positions because you have other parts of the weld assembly in the way. In this case here, I'm just using a drill press and I'm just making the holes now. You'll notice that I put references on the metal. And the reason for that is because the customer needed this to be 1 inch up, the first hole, and then 3 inches between the two holes. And I wanted to make sure when I welded it, I didn't weld it upside down. Without cause this not to actually go on the wall the way they intended it to. Now another issue that was pretty apparent right off the bat was that I used tubing. It was roughly 1 inch by 1 inch and roughly about 1/16 to 1/8 inch in thickness, wall diameter, or wall thickness. And the issue with that is that it's relatively thin, so it's easy to actually cut yourself on that. I had a buddy do that before. And because it's so thin and you have the cap that's so thin on top, it gets kind of tricky because I'm welding with a stick here and it's 1/8 7018 AC. And it's very, very hard to weld without going all the way through it because there is so much power in that. But I've been practicing for quite a few months, and as a result, it came out pretty good. Then after that was just the process of cleaning off the slag and making everything sort of relatively clean. Now, another thing to keep in mind with welding is that you have a lot of heat affected zones. Basically, the heat you generate from the welding can actually curve and turn things around on you pretty quickly. And that's why I did tack welding on the other side and on the edge. And then I was able to do a full weld in the back. And as a result, just clean everything, make everything flush. And then when I turn it around and do the other weld, it's not gonna warp as much. While if I did the other way around, I welded where the two components sort of come together, it would go from 90 degrees to maybe like an 80 degrees or even 75 degrees, depending on how much heat I put into it. And as a result, when I go to do the back side, which is what you see here, nothing would work. Everything would be off. I used double magnets here just to make sure that nothing moved on me while I was doing the welding. Because again, there's a lot of strength in this, but there's also a lot of heat generated in a very specific area. So that was my biggest concern doing this entire project here, was actually just this part here. But it came out fine. I let everything just cool by air. I didn't quench it or anything like that. And then I just ground down the weld. And the reason for grinding it out is basically just aesthetics. I just want to have a nice finish where the two 3/8 plate came together. And you notice that I have the holes in the right position so that when they put it on the wall, it is actually 1 inch high to work perfectly. Now this is another part that was kind of tricky because again, it's a thin walled tube. And if I do it at exactly 45 degrees, which is what you're supposed to do, you actually end up going through the tube. So in this case here, I angled my electrode so that it was a little bit more downwards. So more of the heat was going to the 3/8 rather than the tube. Therefore I don't go through the tube, but it still sort of welds everything together properly. A project like this might seem very, very simple, but actually it's quite complicated. There's a lot of steps involved. And something you got to keep in mind with welding especially is you can have heat affected zones. And what I mean by that is you're using a tremendous amount of heat or amperage, and what you're doing is putting it into the metal, and the metal reacts by expanding. Now it can expand where you're working and so forth, and it can cause a little bit of warping across the project depending on where you're doing the welding. In this case here, welded over here, so you can see here, I made a flush. See if I get the reflection to work, maybe. And I also used the grinder to get this flush. I didn't tack weld these, I actually did full welds. And the reason for that is because I figure if I'm overbuilding something, I might as well really overbuild it. Tack welding probably would have been pretty strong, but if you do full welds around a tube like this here, it's not coming ever apart, it's not ripping anywhere. They'd actually have to rip off the 3/8. This would have to break before this breaks, basically. That's what welding does. You want it to break at the weld, you want it to break next to the weld. So when it comes to custom fabrication of these kind of things, it's a fun little job. It's not really that complicated, really. But I learned a tremendous amount from it, and it just reminded me of when I started CNCKing.com. I just had, the laser behind me here, and I was in my parents' 2-car garage, and I just had half of the garage. And I worked there, and I did all my jobs there. Now I got definitely a bigger shop, more equipment, more everything. But it just started off as, little jobs here, little jobs there. And then over time it builds up, they get more complicated, they get bigger and so forth. And they get more methodical, and that's still kind of fun. So right now I'm doing these kind of things, and I'm doing little stainless steel vaults and stuff like that. A lot of little jobs, but everyone teaches you something. So when it comes to custom fabrication, we can make basically anything for you. Contact me at CNCKing.com. We'll make it for you and ship it right to your door.